Lindsay, can you hear me?
I can. Are we good on your end?
I think so.
Sweet.
I'm going to wait for the thumbs up.
Are we going to be able to go live?
Yes, we are going to be able to go live. And you should see these people in the theater, Lindsay. Oh my gosh, it's full.
Are you teasing me?
I am not. I can count 70 people right here.
Okay, that was worth climbing this hill then.
It was worth it. Sorry, everybody. We're working diligently to make sure that you can actually see Dr. Zano. Sorry, Lindsay. All right, everybody. Well, as we wait to get Dr. Zano up on the screen, we'll go ahead and we'll do a soft start. How about it? My name is Chris, everyone. I work here at the Museum in Education, and I am the curator for the SECU Daily Planet Theater here inside the wonderful, fabulous North Carolina Museum of Natural Sciences. Are you having a wonderful Saturday morning so far? Into a Saturday afternoon. Fantastic. Who here likes science? Show of hands. Okay. Oh, that's not nearly enough people to actually be inside a science museum. No, that's fantastic. I'm so glad that you're all here today. Thanks for joining us. Who here likes dinosaurs? Maybe the better question is, who doesn't like dinosaurs? Okay, good. No, one person. That's fine. We'll work on it. Maybe after today, we'll convince you. Here at the North Carolina Museum of Natural Sciences, We are one of the largest natural history museums in the country. In fact, we are the largest natural history museum in the southeastern United States. Here in our holdings and our collection at the museum, we have more than 4.5 million specimens from the natural world, covering all kinds of disciplines, all kinds of places all over the world. Some of the work that we do here at the museum is paleontology, and at the museum we have our own team of dinosaur and paleontological experts who are going out into the field to collect more specimens to bring back to Raleigh, North Carolina, to not only grow the collection, but to also help us learn more about the way the world used to be from anywhere from just a few thousand years ago out to hundreds of millions of years ago. The collections here at the museum are an impressive diversity of ancient life from all around the world and from many, many different time periods. And part of the reason that we have such an impressive collection of stuff here at the museum is that we have fantastic paleontologists who are intrepid adventurers, explorers, and incredible scientists who travel all over the world in order to find this stuff and help us learn more about what was going on, sometimes in our backyards and sometimes in other parts of the planet. And joining me now, I hope, I'm going to get the thumbs up from the back. Let's rock and roll. Lindsay, are you ready?
Hey, Chris.
Everybody, I want you to meet the head of paleontology here at the North Carolina Museum of Natural Sciences. It's Dr. Lindsay Zano. Hi, Lindsay. Welcome.
Hi, everyone. Happy Saturday.
Lindsay, get us started. Tell us where you're at, what you're doing.
Okay, Chris, we're coming to you live from the San Juan Basin in New Mexico. This is in the upper northwest corner of New Mexico, and in this area we have an incredible array of rocks that were deposited during the Cretaceous, which is my favorite time period. And we've got a crew of about 14 people, including paleontologists from the museum and graduate and undergraduate students from NC State. In fact, right now we have a class, an undergraduate class called Paleontology Field Methods that has a bunch of students who are out learning how to do field work. And we've been here about a week. We got here last weekend, set up a camp in this area. It's a remote camp. There's no running water or electricity and no real cell service. So I had to climb this hill just to get a couple of bars signal to be able to call to y'all to the museum today.
The landscape behind you, Lindsay, looks incredible. It must be exciting to camp out in a place that looks as beautiful as that and do this kind of work.
You know, Chris, this is one of my favorite places. It's absolutely stunning. You can see all of the badlands, the striped badlands behind me in different colors of red and green and white and black. And it's pretty rough terrain in places, so the students are getting a real introduction to how hard it is to excavate fossils and how long it takes. But this is definitely one of my favorite places to do the work.
Besides it being a beautiful landscape, is it also a great place to go do field work because you've made some exciting discoveries this week?
Why, yes. We've been working actually out in this area for almost a decade now, off and on. It's hard to believe. But this is a kind of poorly understood area. Not much is known about the animals that lived in this time period. And this is a rock formation called the Menifee Formation. And it's so poorly understood, we don't even know exactly how old these fossils are yet. So we've brought a team of scientists that are all working together. It's this big collaboration we have at the museum at North Carolina State and other universities around the US and also South Africa. We have some people here from South Africa. And this is part of a big project that we have to understand this really interesting time period in Earth's history called the Cretaceous thermal maximum. And this was a time period when Earth got hotter than it had been in the last 200 million years. So if you go back 200 million years in time, around this time, was when Earth was really, really hot. So what we're trying to do is we're trying to understand the ecosystems that were around before Earth had this hyperthermal or super hot event and then after so that we can understand how climate change back in the Cretaceous affected dinosaurs. We know a lot of dinosaurs went extinct, and not just dinosaurs, but other groups of animals. We don't really understand how that global warming event affected the dinosaur evolution that was happening here. So we've got a team of geologists who are out here. Their job is to figure out the relationship of all of our fossils in space and time. And then we've got some paleoclimatologists, and they're going to take samples of the rocks, and they're going to be able to estimate how hot it was at the time, how much rainfall there was. And then we have ichnologists. These are scientists who study trace fossils. So those are imprints in the rock record left by animals that we don't have body fossils for. So they study things like burrows, footprints. And that can tell us a lot about the ancient environment, like how salty was the water, or what types of invertebrate, soft-bodied animals were here that we're not going to get in the fossil record any other way. So we're not just digging up dinosaurs. We've got this whole team of people out here trying to understand the whole ecosystem and put it in time and space so we can kind of piece together some of this puzzle.
That's amazing. Incredible stuff. Great questions, too. I love that we're out there trying to investigate everything about this ecosystem and this time because it is so poorly understood. Lindsay, can you share with us, have you found any interesting things? What have you, tell us, what have you been digging up these last few days or these last few years even? And I don't know, maybe has what you've found started to give you some clues as to these bigger questions that you've got?
So we, a few years ago, a graduate student from NC State found this locality down here, and what he found were some ankylosaur bones sticking out of the base of a really big hill, like a 30 to 40 foot hill. And so we collected the shoulder and the upper arm of that ankylosaur, and we haven't had a chance to come back to see if it might be worth opening a big quarry or not. So for the past week, we've been sort of digging carefully into this hill, trying to figure out, is there actually more bone here? Because taking that 30 feet of rock down would take a crew of 15 people a couple of weeks to do. So I'd say we're kind of dating this site right now, Chris. We're trying to figure out, like, do we want to make a long-term commitment here? Is it worth taking down half the hill, or maybe is it just scrappy material and it's not worth doing that? So we've got a couple teams sort of digging small areas into the base of the hill to try and figure out what we've got here. And actually what we're finding is there's a lot of different layers of bone. So we've got a hind limb, like the upper leg bone of a horned dinosaur, a ceratopsian. This is similar to like a triceratops. We've got the foot of a duck-billed dinosaur or a hadrosaur dinosaur in another spot. We've got some vertebrae and some more bones of that ankylosaur or armored dinosaur. So we've kind of got bone coming out all over the place, and we're just trying to sort out what exactly we want to do with that. So those are kinds of the animals that are around in this environment. There are also tyrannosaurs. 2 days ago, I found a nice tailbone of a large tyrannosaur out here. So we've got a whole diversity of dinosaurs. And then we've also got crocodiles, tons of turtles. We've got big fish, big giant fish that were living here. And the other thing that's turning up in this quarry that's really awesome are plants. We've got really beautiful plant fossils. So we're collecting all of those things.
Lindsay, that doesn't look like a place that crocodiles and fish would live.
I know. Well, actually, this looks like a pretty barren environment today, but back in the Cretaceous, this was a super wet, lush environment. This would have been like a delta plain, like think of Mississippi Delta, for example. And there was a seaway that cut North America in two at the time. Remember I told you it was really hot time period, Chris? Well, sea level was really high, just like sea level is rising today because the global warming is raising Earth's temperature. Sea level in the Cretaceous rose as well. And so this area, even though it's a desert now, was once on the shoreline of a massive seaway. And there were lots of rivers and lakes and streams for all these aquatic animals to live in.
Fascinating stuff. Well, everybody who's here inside the theater or watching online on YouTube, you can ask questions as well of Dr. Lindsay Zano. If you're here in the room with me and you've got something you want to know more about our paleontologists working in the field, just wave at me, let me know you've got a question, and I can bring a microphone to you, or you can actually even come up here on stage with me and talk to Dr. Zano yourself. So if you've got questions and you're here on the first floor, just let me know. You can come up and chat. If you're up there on the balconies on the second or third floor, I can see y'all. Just wave down at me if you've got questions. I can call on you, then you can yell at me, and then I'll use the microphone to repeat the questions so that everybody can hear. And if you're watching online, I've got your questions pulled up right here. I've got the YouTube chat going so that we can see what everybody is talking about. Lindsay, it looks like the first thing I should let you know from the chat is that everyone, all of Madison's friends and family and teachers and colleagues are in the chat, and they're so happy.
I'll pass that on to Madison. She's doing great. She's an amazing digger with the shovel. She's been keeping up with me.
Fantastic stuff. So, Lindsay, you said that a while back, one of your students happened to find an ankylosaur, and so that was where you knew to start looking for more of those fossils for that particular type of dinosaur. But how did y'all find that to begin with? Because I don't know how you'd find anything out there in that landscape. How do you find just a few, like just a shoulder bone sticking out of a hillside?
Well, it's not rocket science. Paleontology prospecting essentially involves us walking around on these barren hillsides and looking for places where bones are actually eroding out of the ground. And as they erode out, they break up into pieces and they sort of trickle down that hill. So you look for these little pieces of bone. And the trick is learning to identify bone from rock, because you can see there's a lot of rock scattered around on these hills as well. So you have to get trained to recognize what's bone versus what's rock. And then you trace those pieces up, you try and find the layer that the bone is actually eroding out of. And with any luck, you'll see something in place. And then that's where we know we have to start digging.
That sounds difficult.
It's fun. It's great. I love it. I love the solitude. I love hiking out here all day and just zenning out, got some music going, hiking around, looking for dinosaurs, and you never know what you're going to find around every single corner, which just kind of keeps you going all day and can keep you going for months, really. The excitement of thinking around this corner could be something really, really cool.
Have you been able to do any prospecting since getting to New Mexico for this field season? And do you have any leads on anything exciting?
We have done a little bit of prospecting. You know, we just got here, so our priority has been getting the quarries open so that everybody can get to work. But we've done a little bit of prospecting, and, you know, I know everyone's really excited about dinosaurs, but like I said, one of our goals here is to collect all of the things that were living with the dinosaurs. So we found some nice, what we call microfossil sites. And these are places where tiny bones accumulate, things like fish scales and turtle bits and claw teeth. And those are really important for us because they give us sort of a quick snapshot of everything that was living here, but also because we can do chemistry on those tiny fossils, and we can build like a food pyramid from the ecosystem, like a trophic network of who's eating who and what. And that can give us a lot of information about how the animals were interacting in the environment. So we're really excited. Microfossils are hard to find out here. So we're pretty excited to sit for a while and collect some of those microfossils for geochemical work.
Oh, okay, why are microfossils tough? I know we have other dig sites like Montana where you work, and we collect lots of microfossils. Why is it different there in New Mexico?
You know, it's all about the preservation, how the fossils are getting buried in the particular environment. So microfossils are kind of sorted by water in the ecosystem. So you have to have the right conditions for them to accumulate very densely in certain places. And you have to be able to see them. I mean, I don't know if you can see the hill that I'm on, but it's like covered in fragments. And so it can be really hard to spot them. You have to kind of crawl around and get your face really close to the ground to even be able to see tiny fossils out here. So it's kind of a collection bias and a preservational bias that makes it difficult out here in the Menifee.
Much better to just go find an entire ankylosaur skeleton.
It's a lot easier.
All All right. Question from the audience. Did you want to come up? Okay, what's your question? All right, question from the audience, Lindsay. Do you do dating of the material like carbon dating in the field, or do you have to bring it all back into the lab here at the museum before you can start investigating ages?
Great question. We don't do it in the field. What we're doing out here is we're looking for ash layers or places where volcanic material accumulated. And we unfortunately can't use carbon dating because it's not old enough. It doesn't allow us to get into the millions of years. But we use uranium lead dating, which has a much longer half-life. And we'll collect those samples. We'll collect bags of sediment, rocks, basically bags of rocks, and we'll haul them back to camp. And then we'll ship those to labs that we collaborate with. Our lab that we collaborate the most with is in Idaho. And then they will break down the rocks, pull out the little volcanic crystals, and they'll shoot them with lasers, and they'll be able to determine how long ago those crystals formed when they were in a volcano. And that will tell us the age of the different layers. And then once we put all of our sites in between those layers, then we'll know pretty much exactly how old each one of our sites are.
Wow, that's a fun way to use a volcano.
It's great. We love volcanoes. They weren't great for the dinosaurs, but they're sure great for paleontology.
Okay, another question. Ooh, how do you differentiate the different types of bones, or the different bones you find from different species? Did I get that right?
Well, that's kind of what you do when you train to be a paleontologist. You have to know a lot about geology, but you have to know a lot about anatomy. So we spend a lot of time learning about the shape of the bones of different types of animals, and including, like we said, turtles and crocodiles and mammals and all kinds of things. But we go around to museums and study the collections, Chris, like you were talking about our 4.5 million specimens. What do we do with all that? Well, what we do is we use it as a resource. And so we'll go into museums around the world and we'll study in detail the shape of the bones of different types of dinosaurs so that when we find a bone in the field, we're able to figure out what type of dinosaur it is. I will say, though, that when we dig bones up in the field, we try to leave them encased in rock as much as possible to protect them. We don't try and like chisel them all out of the rock in the field. So we get our field IDs wrong a lot because we're often looking at just a tiny piece of the bone instead of the whole thing. So, I mean, paleontologists misidentify things all the time that they're digging up. And then we don't really know what it is sometimes till we get it back to the lab at the museum, Chris, like we have there, and watch the preparators finally get it cleaned up. And we go, oh, actually, it's a bone from this type of dinosaur. It's this bone when I thought it was something else in the field.
So once you get it out of the ground and it makes its way back to Raleigh, it goes in a spot like in the Dueling Dinosaur Lab or upstairs on the 3rd floor here in the Paleontology Research Lab. And that's where the sort of the real science kicks in of trying to understand not only what species of dinosaur it might be, but then all of the other questions that you've got about what that dinosaur was doing there at that time and what was going on in the environment, right?
That's right. All we're doing out here is taking samples and taking data and bringing it back to the museum, and that's where the science happens.
So earlier you mentioned, for example, and there was a question about it in the chat, you said you found a piece of a tyrannosaur. You wouldn't maybe right now know what species of tyrannosaur you've got, except for maybe just like a broad idea because of the time layer of rock that you're working in?
Yeah, I mean, there's a species of tyrannosaur named from the Menifee, Dinomater, but its tail bones are not really different from a lot of other tyrannosaurs, you know, so it's not a bone that we can use to identify it to the species level. We can just say, well, this is a tyrannosaur tail bone, but we're not sure what species it is unless we find something that, what we call diagnostic. So it's so different and unique to that species, and no other species has that bump or that groove or that shape or something, that horn. That if we found that bone, that would tell us, oh yeah, this is Dinoterra, for example. But a tailbone is pretty generic bone for tyrannosaurs in most cases, so we don't know exactly what species it is.
Oh, interesting. So you'd really like to find particular bones, particular features of these animals in order to be able to do the identification work. If you don't have those or can't find them, do you just kind of have to like bury it and then walk away and try and find another one? Do you still bring them back to the museum? What happens in those cases?
Oh, we definitely still bring them back to the museum because it's still good information about that there was a tyrannosaur here and it was this size. And sometimes we can do other things other than figuring out exactly what species it is. Sometimes we can cut into the bone and figure out how old that individual was. And there's lots of information we can get other than just what species it is. So we collect most things as long as they're in decent condition that we find. And also because you never know when that information will become important. And that's one of the essential reasons to have museum collections is it's not about what we think we need now. It's about what some of the young kids in the audience who want to grow up to be paleontologists will need 30 years from now. When they're doing their science, they may say, if I only had a tyrannosaur tailbone from the Menifee, I could answer this question. And that's why we have collections, because we're preserving this information for the future, because we never know when it's going to become important.
So how much stuff do you think you'll collect in the field this summer? How much of it will you have to wait and go back next summer to get? How many truckloads of rocks and fossils are you bringing back to Raleigh from New Mexico?
Probably two truckloads or so. We have 2 trucks and a trailer out here. We'll be out in the Menifee for a month. This is the end of our first week of a month. And then we'll be going to Utah for about 8 weeks or so, like a month and a half, almost 2 months. And then the crew will be going to Montana for the rest of the summer. And so we load up the trucks and the trailer and we come out west and we stay out west until the semester starts again at the university. So we'll be collecting a lot of stuff, Chris. So I hope you're making room over the summer.
I went and I told Eric and Jen and Lisa to just start pushing some boxes. You can have my office if you want it.
Okay.
You can fill my office. It's not very big. Maybe there's room here in the theater. We'll just stack them up on the edges of the walls next to the Dino Lab. You can have this room too. So some more questions that are coming up for you. Are the fossils mostly from one period of time out there, or do they range across more and different prehistoric periods?
Well, we're right now only interested in digging in this set of rocks that represents one sort of time period. But if we were to drive a little bit north, we would be moving into younger and younger rocks. And if we were to drive a little bit south, we'd be moving into older and older rocks. So this whole area is kind of like a staircase, and you can kind of go through time as you move north to south. So we've sort of picked the spot that's the right time for our research questions. But if you wanted to look at younger dinosaurs, you would just go another, say, 60 miles north. And if you wanted to get closer to the seaway and go back in time when the seaway was a little bit closer and collect things like Cretaceous shark's teeth, you would just go a little bit south of here.
That is so cool. That's so incredible to be able to do, to think about just all those rock layers and all of the information that's in each one, and that you just go sort of find whatever rock is at the top and look around and you can find incredible stuff.
Yeah, I guess it's like being a time traveler, right? Like if you were to hike, I don't know if y'all can see the quarry back here. I know everyone's like a tiny little ant, but if you were just hike up and down this hill, you're just traveling in time.
So you've got about 3 more weeks out there. Anything you hope you find? I mean, I know you're
Chris,
like
I'm out here looking for tyrannosaurs. So we have some material. We collected a nice hind limb of a tyrannosaur. We've got bits and bobs, tail bits, pelvis, some ribs, some lower limbs and things, but we haven't found a skull yet, and that's my #1 goal this year. We'll see.
Do you think there's one out there?
Oh, there's definitely one out here. We'll just see if it's poking out on the surface yet and if I can find it.
I think if anybody could find it, Dr. Zano, it is you.
Well, thank you. That's good luck. I'll take it. We need everyone cross their fingers out in the audience.
Lindsay, no joke, they literally all did that for you. We've got our hopes up for you. It's all riding on you.
Great.
Bring us back a Tyrannosaur skull. We want to see it.
Okay.
Well, Lindsay, thanks for taking the time out of your busy day. I know y'all got a lot of work. It's 7 days a week, long hours every day, but thanks for taking a break for us to call in and let us know what's going on out there in New Mexico and the great work you've got going on.
Absolutely, Chris. It's great to check in with everyone. We'll check in with you in a week, and we've got we've been a little slow on Instagram and Twitter just while we're getting kick-started here, but we're going to be doing some more live updates on social so people can follow us there. And if anyone wants to help donate to our dinosaur program to help us out here, we've got, I think, some links where people can send us some small donations to help feed the students out here. They're working hard.
Excellent stuff. Well, Lindsay, be safe out there. Give the team our best, and good luck.
Okay, thanks, Chris. Y'all have a great weekend. I'll talk to you next week.
Everybody, make sure you check out naturalsciences.org. That's the museum's website. There you can see information about upcoming programs, including the next installments for Dino Dig Live. We'll be checking in with the paleontology team all summer long, June, July, and August, from all of their sites all across the West. So don't miss out on one of these great programs. Stay clued in to what's happening. Make sure that you're following the museum on social media. We'll be sharing updates as well. Dr. Zano's team is at Expedition Live on social media, and then, of course, the museum is Natural Sciences on social media. Thanks for coming out today, everybody. Thanks for tuning in online and joining us. It was great to spend time with you all. Enjoy the rest of your Saturday here at the museum or wherever you happen to be. And Lindsay, it looks like you've got gorgeous weather. Good luck on those tyrannosaurs.
Okay, thanks, Chris.
All right. Bye, everybody.